So a Stag and Doe has 7 Toronto Maple Leaf ticket prizes and wants to give away 3 of them randomly. There are 4 blue level tickets, 2 gold level tickets, and 1 platinum level ticket. The tickets are mixed in a bag and 3 are drawn at random. What is the probability that none of the prizes are the platinum ticket? Now, this is a hypergeometric distribution probability problem, because we are not replacing the tickets. So one is drawn, then on the second draw, the probability is dependent on what happened on the first draw. So here, n is the total number of possible outcomes, and that would be the total number of tickets, which is 7. A is the possible number of successful outcomes. So we're going to consider successful as a platinum ticket being drawn. So A is equal to 1. R is the number of dependent trials, so the number of draws. So R here is equal to 3. And X is the number of successes. So we were interested in what's the probability that we are not successful at drawing a platinum ticket at all. So X is going to be 0. So when we substitute the equation here for a hypergeometric probability distribution, then it's going to be P probability of 0 is equal to 1 choose 0 times 6, which is going to be 7 minus 1, which is 6 other tickets other than platinum, choose 3. So that means that here the number of ways we can pick 0 platinum tickets out of 1, and here the number of ways we can pick 3 tickets out of the remaining 6 tickets that are other than platinum, either golds or blues. And we're going to divide that by 7 choose 3, which means the number of ways that we can choose 3 tickets out of 7, and that's going to be our total subset, or total sample set. So the number of ways we can choose 0 tickets out of 1 is just 1 times 6 choose 3, so is 20, over 7 choose 3 is 35. Combination of that. So that's going to be 20 over 35, which works out to be approximately 0.5714. So that's the probability of selecting no platinum ticket, so almost a 50% probability of not selecting a platinum ticket if you're going to choose 3 tickets out of the 7. Now, the expected number of blues that we would expect to be drawn here. So here, in this case, R would be still 3. A is the number of possible successes. So if we're going to now consider blue as being the successful ticket number, being drawn, so we've got 4 blues to choose from. So that's going to be our A divided by the number of possible outcomes, which is still going to be our 7. So this works out to be 12 divided by 7, which is approximately 1.714. So we'd expect 1.714 blue tickets to be drawn.